morning. How are you? All right, so ladies and gentlemen, we're going to walk through the calculator. We will walk through the calculator tomorrow as well, doing the same exact thing to make sure everything is all situated. Got one broken? Oh, no, it's just the incanter. I'm going to say it real quick. All right. Okay. So I am on our review, which was page. Oh, yeah. All right, 124. So. So we are going back to number 13 on page 127, but we're going to make sure we do this. So we're going to walk through the calculator step by step. Okay? Now, guys and girls, try and stay with me. Okay? The hard thing about teaching these calculators, oh, where'd you go? Where's this button? Oh, where'd it go? Yesterday at lunch I went and saw my mom. Oh, where are you at now? Pay attention to what we're doing here because you're going to be lost. All right, so it looks like we have information already on our calculator. Let's get rid of it. So I'm going to go, calculator's on, yes?
Yes. No, it's no.
Good. I'm going to go second, with me, plus. I'm stopping right there. Is everybody there?
Yeah.
Is anybody not there? All right, I'm going to go down to reset, and I'm going to hit all RAM and number 2. So what that does is just kind of goes, whoosh, everything's wiped off. Okay, and once you've got to this point, you just go ahead and hit clear, and it'll take you back to a blank screen. Did everybody accomplish that without any problems? Sweet. All right, so we want to now turn our diagnostics back on so it gives us back our R and our R squared value. Okay? So now I'm going to hit second and 0. That's going to take me to my catalog. Okay? I can arrow all the way down to diagnostics on, which is probably a couple hundred things down. Or I could realize that I have the alphabet in mine's green letters. So I'm going to go to my x to the minus 1, which is D, and then I'm going to arrow down to diagnostics. Once I find diagnostics, I hit enter, and I hit enter a second time.
Why do you have to put done again?
Because when we reset the whole thing, it turns it off. So we want to.
Why do you have to make it done?
Well, now it's turned the diagnostics on. It just turns that feature of the calculator on. So, everyone feel okay so far? So now we are ready to enter data. Anyone want to remember where we enter data at? Stat?
Stat.
Good. So it's the red button I just hit. And I'm going to edit. And my list 1 will be my x values. So my x values will be 1 through 8. And if you make an error, just arrow back up to where your error is and change it.
Mister.
Yep.
How come you don't do just how to do all that and clear it so we don't keep we're most likely gonna forget. So how can you just make
I will,
a little small thing and use it?
because I'll always lead you through it. And by the time we do it 8 or 9 times together as a class, you'll probably have it down. You'll know it. I promise. All right. That was my list 1. My list 2, my y component, is going to be these values. So if you don't have page 127, number 13 at, you can look at it, or you can look up here. that's my data.
Mr. Actually, didn't put a 9.
Okay, so arrow back to where you're at, put the appropriate piece, put the appropriate number, hit enter, and it will replace it. Did it work? Or do you have 9 at the bottom of list 1?
Yeah, I'm not at the bottom of this
Oh, okay, so go hover above the 9.
one. No, let's put it.
So list 1 is 1 through 8. List 2 is 24 with the 1, 2, and then this goes with 28 with the 2, 3 with 33, 4 with 38, 5 with 41, 6 with 45, 7 with 48, and 8 with 51. Those are all points, but the calculator doesn't allow you to plug a point in here. That has take your x component, put it in, and put your y component in. Everything okay? May I move to the next step? So being that we reset the calculator, we turned our stat plot off. So let's turn the stat plot back on. So I'm going to hit second y equals. You're going to hit number 1. Once it gets there, just hit enter and don't do anything else. Okay? Had a student yesterday go down and say, oh, look, I made it yellow. And it's like, hey, I can't really see the yellow. Just leave it. Leave it with the default. It'll work. Oh, but I like yellow. Did I ask you that? You can't see the yellow on the screen there, Copernicus. Astrologer. Astronomy. All right. So once we're at this point, our stat plot is ready to turn on. If we hit graph right now, it takes us to the -10 to +10. If I hit zoom and then stat for our data, it'll then change our window on our calculator to allow that to take place.
So hit stat, zoom.
Zoom and then zoom stat. Number 9. Yeah.
Oh. There we go.
Hit zoom.
Zoom and then hit on the
Down
button.
to
Oh.
everyone have something that kind of looks like that? All right. So we can now ask our calculator to find us the line of best fit. Okay? So it hasn't generated this line of best fit yet. So I'm going to go back and I'm going to hit stat. And I'm going to go over to calculator. Arrow over to calculate. And then I go down to the linear regression, which is number 4. Arrow down to where it gets to calculate. Notice I didn't change anything. And hit enter. And boom. Okay, stat. Move over to calculate. Down to linear regression. Enter. Enter one more time. Did it calculate it? Move down to calculate.
Mine's different.
You had Q for your list 1. I accidentally hit a button. You want the Q, the letter. So now it's good. All right. So at this point, I feel it would be important that you kind of write down the line of best fit. So I have y equals ax plus b. We know it as y equals mx plus b. So a is my slope in this problem. So I'm going to take usually about the 2 decimal places. So my slope is 3.90x. And then my b value is plus 20.93 rounded to 2 places. Does that make sense? All right, so what does my slope mean in the context of this problem? Well, my y component of this problem is the height or the length of a child in inches. So for every 3.9 inches extra or longer the child is, 1 year took place of life. So basically you're growing about 4 inches a year. Okay. Now, does that stay consistent throughout life?
No.
No, we get to a certain height and stop growing, right? So we're kind of bounded by this one, which is fine. Use your linear regression capabilities of your calculator to create the least squares line of regression, which is this. Sketch the line on the above graph. Well, we don't have a graph, but if we're going to graph this in a moment. I'm not there yet. Use your equation to calculate the height of the child. Okay, so I'm going to hold this here. And the nice thing about it is if I have this here, if I switch my board back to this, I found this is my linear equation. Okay, so let's talk about the slope real quick. You grow, or a child grows, 3.9 inches for every 1 year. Okay, and again, this is bounded. Usually when you get to about 15 or 16 years of age, you stop growing, or you're growing slow significantly. Okay? What does my y-intercept mean in the context of this problem? What does that mean in the context of this problem? What does 0, 20.93 mean in the context of this problem?
Ooh,
What?
it's the starting point.
Right.
Yeah.
You were born.
Like 20.93.
Yeah. Now, is that the same for everybody? No. I mean, I bet you they grab this data just randomly. They're making this up. This is not true factual stuff. Okay? We don't base life based on what we learned in Algebra 1. But we're just using the data that's given, and what does our data dictate to us? Basically, with this particular study that's taken place, we are showing that when a child's born, they are 20.93 inches tall, or that's their length if they're laying down. Is that okay? And again, we're in Algebra 1, so this is not a scientific study. We didn't discover some new discovery of life. It's just the thought process we're trying to go through with the class. Okay? So, what does my y-intercept mean in the context of this problem? In this study, when a person is born, they are 20.93 inches in length. That's all it means. Okay? Again, what's the key here? In the context of this problem. Am I able to apply that context of the problem to the world? No. We're taking what the problem context is, and we're applying it. Okay? So, use your equation to estimate the child at 12 years old. Okay? So let's figure this out real quick. What is the label of my x? Is my x height or age in years? Age in years. What is my y component? Is that age in years or height? Height. It's just the height, and this happens to be in inches. Okay, double tick mark means inches. Is that okay?
Wait.
We're not done with the problem yet. We haven't answered it. Okay, so letter C says use our equation to estimate the height of a child in 12 years. So where am I going to plug a 12 in to our given equation that we just used? where do I plug it in? Do I plug it in for 20.93? No, that'd be ridiculous plugging a number in for a number. Do I plug it in for 3.90?
Yes.
I replace 3.90 with 20? No, I plug it in for x because I know x is the age in years. So I'm going to take my equation, and this was the equation that our calculator generated, and we rounded it to 2 decimal places so we didn't have to deal with something that's out 10 digits. So then I'm going to go y equals 3.90 times 12, because 12 years of age, plus 20.93. So if you plug that into your calculator, if you just hit quit out of here, or clear, oh shoot, it's that clear. If I hit clear, if I go and I figure out my problem, I have 3.90 times 12 plus 20.93, okay? This is where x used to live, agreed?
Yeah.
I replaced x with my 12 because we want to know how tall a child is at 12 years old. 67.73 inches. That's, yeah, a pretty tall 12-year-old. I mean, that is 5'7" tall. Almost 5'8". Some 12-year-olds might be that, but a lot of times they're not. Okay? So, again, we're basing it on our model. Okay? And then what does the slope of your line represent? Didn't we already talk about what the slope represented? You grow 3.9 inches for every 1 year alive. Now, would this equation make sense? Like, is there a point where this stops making sense? Well, let's do this. Let's figure out how tall Mr. Stirrup is based on age. Okay, I'm 46. Okay. Oh, thanks, man. All right, I am 200.33 inches tall. Man, I'm tall. I knew I was tall. Hey. I'm SMall. Yeah, if I wanted to figure this out, if I divide that by 12, because there's 12 inches, that would mean I'm 16.7 feet tall. What? I know. So again, is there a certain range where this is going to work for us? Yeah. Yes. Is there a certain time where we would probably shut this off? So childhood birth charts are a real thing, actually, and they show where you fall with the data of what they have gathered for many, many generations of kids. Okay? And your growth chart, like if you go in and you're like, okay, and all of you probably remember this, you've probably gone to the doctor a couple of times. When you're much younger, you go a lot more often than when you start getting older and older. Okay? I've been fortunate. I go to the doctor once a year just for a physical. Okay? I guess from time to time I might have to go if I had, got a bad enough sinus infection that, my body didn't, get rid of. But for the most part, as an adult, you have a relatively healthier life than when you were first a child. What? Does anyone know why you're sicker as a child than you are as an adult? Yeah, your immune system. So this is how your immune system works. Here's a virus, and your immune system's like, oh, hey, virus, you're kind of fun to play with. Oh, now I'm sick. Okay? So you get these, get colds and flus and ailments as a child because things are introduced to your body, and your body's like, hey, it's my new friend. And unfortunately, that new friend, you ever have that one person you thought they were a cool person when you first met them, and then you know them later, and you're like, they're a big jerk? That's kind of what your immune system's doing. So your immune system kind of says, do you know that person right now where if you're like, you see them, you might be like, I'm not going to go that way. Or they call on your phone And you look at it and like, I'm not going to talk to them. You know the person?
Yep.
That's your immune system. Your immune system does that with colds and viruses and different bugs. Okay, and it's just kind of the nature of life. So when you are a younger child, you do go to the doctor a lot more often, especially after when you're first born. There's certain, we recommend you bring your child at this many months, this many months, this many months, then this many years, this many years, this many years, and it's just what the medical professionals have said. If you don't follow it, you're still going to grow. It's just they're making sure that they want to prevent things from being bad. Yeah.
What about that disease with chickenpox when you grow older?
Oh, shingles.
Shingles?
Shingles.
Yeah.
Oh yeah.
Those hurt.
Oh yeah.
Those
So
are
so shingles. So the virus of chickenpox. So I had chickenpox when I was in 4th grade. And chickenpox is not a horrific disease, meaning you don't die from it. If you get it older in life, it can mess up certain portions of your body. So the younger you are, if you get chickenpox, but a lot of you might have gotten the vaccine against chickenpox, which you're pretty fortunate because they gave you the vaccine that your body recognized the virus, built the antibodies to it. And if you got the vaccine for chickenpox, you are immune to shingles. If you're like me and the chickenpox vaccine hadn't come out yet, I had chickenpox as a kid. So when I get to age 58, 59, which is a few years from now, I will have to go get a shingles vaccine. Or I could have shingles. And shingles is basically, it's an open sore on your skin. It's not like bleeding out. It's just like, it looks like a blister.
Yeah.
And when it opens up, it exposes all of those nerve cells to the air. And your nerves and air aren't friends. Your nerves have a barrier to air called skin. Okay? So when you get shingles as an adult, it burns. It burns like crazy, and there's really not anything that you can put on the shingle pock that lowers it. So
What is chickenpox like?
Well, the weird thing about chickenpox is this. They tell you, don't itch it. Want to know what chickenpox do? They itch like crazy. So when kids got chickenpox, you put socks on your hands when you'd sleep. Okay, so you didn't have your fingernails to scratch. Now here's the bad thing. So when I got chickenpox when I was in 4th grade, I was playing Pop Warner football. So I went to school, and I wasn't feeling all that good. Mom sent me to football practice that night. The more active you are with chickenpox, the more you get. I went through our entire football practice with chickenpox. My entire team came down with chickenpox. And it takes you out of the equation for about 2 weeks.
It's contagious.
It's really contagious, yeah. But because they knew that chickenpox was a bad thing for people to get later in life, and they didn't have a vaccine at the time. When you would find out a kid in your neighborhood had chickenpox, your parents always say, "Hey, go play with Freddie. He has chickenpox." I mean, that's how demented we were as society. Hey, go play with this kid with this really contagious disease so you catch it. Because they knew that later in life you didn't want to catch it because it was bad later in life. There was a group out there that, because chickenpox doesn't happen as often, they still want their children to get chickenpox because they don't feel the vaccine is a good thing, or they're immune suppressant to the vaccine, so it wouldn't work for them. So there was a group of parents out of California that, this is really gross. Their child had chickenpox, so they gave their child a lollipop to suck on. They then took that lollipop their child sucked on and would send it to anybody who wanted this lollipop. Then they would take that lollipop that their kid sucked on and say, "Here, this is already a partially eaten lollipop, but you get to eat it now." So then that next child would then get chickenpox. There's a parent group out of California that are indicted and in federal prison because they shipped a live virus through the United States Postal Service. Make that one work.
Oh, yeah.
But could you imagine that? Could you imagine your mom going, "Here, A kid with chickenpox started eating this lollipop, but here, son or daughter, you can have it. Oh, gee, thanks. I don't know. There's times I'm curious how the human species has survived this long. I think we got some people that do some creative things in life. I
You're
don't know.
saying they went to federal prison?
Federal prison because they shipped chicken pox, which is highly illegal. It's biochemical warfare, and it falls under federal jurisdiction. And being as federal, I mean, it's a serious offense. So they would have been in less trouble if they would have sent their child by themselves on an airplane and had some other family pick it up and say, "Here, you can play with my kid who has chicken pox." I mean, that's the long and the short of it, because it went into a postage stamped thing, and that's regulated by the United States government. It's biochemical warfare. Yeah, it's bad. Huh? Oh, I have no idea.
That's probably like.
Well, figure this. There are terrorists that are in prison for the rest of their lives because of trying to do the same thing. The Unabomber, yeah, he sent bombs through the postage. He also sent viruses through the postage. And he's in jail for the rest of his life. So, yeah. It was just some virus that existed.
So if it is, why wouldn't you just
I mean, there was all kinds of things, like you would itch around the pock. If you itched the pock, it
spread?
no, it didn't spread, but it gave you a scar. And this, I don't know, its scar looked like I don't know, you could probably find it pretty easy. It's just, it looks like an indentation, like a crater in your skin.
If you popped it.
Mm-hmm. But I will tell you, like, I bet you on the back of my head, I don't know. I think the scars go away, but I remember the one thing that kind of made your itching go away is you took a hot bath in this, I don't know, soapy solution that wasn't like normal soap. But I remember when I laid back in the bathtub, I pushed my head against the bathtub, and you could feel it was like a bunch of zits. I mean, that's what chickenpox is. And I felt them go, all pop. Oh, yeah. There, my buddy, he had him under his fingernail. And I remember I went over to his house. I had already had him. I think it was probably me that gave it to him. And he's like, "Yeah, check this out." And he pushes his fingernail, and
Oh,
yeah,
gross.
it's good.
How did we get on this topic?
Babies. Oh, yeah. All right. So did everybody get the review done?
Yeah.
Okay, this coming out to you right now is the take-home test. You can work on it together. I think the part you should probably hit right away on this together is the calculator portion. What do you think? Remember, guys and girls, I have to warn you because there are some of you that still insist on putting arbitrary answers in and acting like it's going to be correct. I correct this for accuracy. Trust me, I gave this to you, right? So if the answer is supposed to be y equals 2/3 x plus 7, and you give me an answer of 12, you got it wrong. So please work amongst each other. You have 10 minutes to get a good start on this.
If there's no, so for number 6, you have y equals 5x.
Yeah, where's the y-intercept?
Y-intercept is